Okay, now let's move on to our next question. Polynomial functions are one type of continuous functions. The graph of a continuous function is unbroken. The graph of a discontinuous function has breaks or holes in it. And in Algebra 2, we're dealing with continuous functions. All of our functions have no breaks or no holes. Discontinuous functions, when you get into trig and calc, you will see discontinuous functions. And in Algebra 2, you'll be introduced to these right here with asymptotes, but that's for a later lesson. Let's come down to exercise 3. Draw a quick sketch of each polynomial and describe the end behavior of each function. So now we're asked about end behavior. So let's look at our first polynomial. Let's bring our calculator back up. Go to our stat plot, y equals, clear out what's in here. And this says negative x cubed plus x squared plus 3x.
You're in the building, you're in the hallway, you're not with the teacher, it's time to go home. Make sure you call your parents and plan to leave the building right away. Students, if you are in the hall and you are not with the teacher, you're not being supervised, you need to call your parents or leave the building right away.
Okay, we had a little interruption there, but I'm not going to stop this recording. I'm going to keep on going. All right, so negative x cubed plus x squared plus 3x minus 1. Again, we see that our highest exponent is 3, and we have two terms. Here's our first term, here's our second term. Now, we want to find the local max and local min. We also want to find the zeros so that we can sketch. In order to find our, well, let's start with our minimum point. Second, trace option 3, minimum. And the minimum point, right there, left bound. Move over here, right bound, guess. And it says that our minimum point is at negative 0.72 and at negative 2.26, roughly. So negative 0.72 and 0.72 and negative 2.26, say approximately here. So we plot our minimum point. Now let's look at our maximum point. Second trace, maximum, option 4. We scroll up, left bound, come over right bound, guess. It's saying that our maximum point is at 1.36 and 2.41. So 1.36, 2.41, approximately there. Now we want to find our zeros, and there are 1, 2, 3 zeros. So second trace, option 2 for 0, and we scroll over, left bound, right bound, guess, and it's saying negative 1.48. So negative 1.48 approximately there. Let's look for a second 0. It looks like it's right at 0, but we want to double check there. So second trace, option 2, 0. We'll scroll over, left bound, right bound, guess. What error? No sign change. We don't want that. Let's try that again here. So second trace, 0. It's our left bound. Go back over. It's our right bound. And guess. And it says that it's at 0.31. So really tiny in here. 0.31. And then let's look for our last 0. Second trace, 0. So with all of these decimals, these are probably complex roots that we're finding. So left bound, right bound, guess. And it says 2.17. So roughly about in here. So now I've traced or sketched my maximum point, my minimum point, and my zeros. Then I'm going to use those two dots in order to connect for my graph. Okay, I put the arrows on the end to indicate that these lines keep going. So it looks something like my graph. Now we're asked about end behavior. Okay, well, if we look at the end behavior over here as x goes towards positive infinity, because this is my x-axis and this is my y-axis, correct? We should all know that. As my x's are going towards positive infinity, my y's, or my f of x, are going towards negative infinity. F of x goes towards negative infinity. Okay. Now, conversely, as my x's go towards negative infinity, my y's are going towards positive infinity. As x goes towards negative infinity, my y's, or my f of x, is going towards positive infinity. So that is the end behavior of this particular polynomial. On the ends here, x is going towards positive infinity, y is going towards negative infinity. This way, x is going towards negative infinity, y is going towards positive infinity. So that's the end behavior of this particular polynomial. Okay, so we've covered a lot with this particular video. So try the other examples on your own. All right, good luck.